Balancing cropland use for a sustainable food system. Global crop production will always play the central role in the provision of nutrition to the world's population. Not enough crop food production would mean insufficient nutrients to meet global population requirements, with subsequent higher rates of malnutrition. However, simply increasing crop production and cropland use are not necessarily the right answer. These pose environmental sustainability risks like deforestation and loss of biodiversity. Sustainable future cropland use will need to balance food production requirement against the environmental, economic and social impacts of land use for crops. A recent SNI publication details modelling work to help understand this balance. In this research, a mathematical model was built for forecasting the future cropland required to produce a given quantity of crop food biomass. It was then integrated into the Delta model, an existing food system model calculating global nutrient availability from global food production. The model uses national crop yield data from the United Nations for 137 crops in nearly 200 countries. This data shows us where crops are grown in the highest yield and which crops use the most land. The model calculates the scope to increase yields or to increase production through additional use of land. Potential improvements to crop yields were assessed based on the difference in these yields in different locations in the world. Some crops, such as soy and sugarcane, showed very little variation globally, while others, particularly nut crops, had huge variations in yield between the best performing and the poorest performing locations. We used this data to investigate which crops would see the greatest increase in production if the lower yielding land could achieve the yield of the best performing land. The greatest potential for increasing global food production was found for the most widely grown crops, maize, wheat and rice, which were also demonstrated to be of high nutritional significance. By incorporating this data into the Delta model, we were also able to see how important crop production is for the global supply of nutrients. Plant foods were responsible for the majority of nutrient supply for most nutrients in 2018, with some exceptions like calcium, vitamin B12 and certain amino acids. Cereal crops were the most important, largely due to their high global production and consumption. They are not necessarily the richest sources of nutrients, but are an important source because we consume so much of them. Oil crops and vegetables also played an important role. The model also lets us predict the amount of cropland that will be needed for various future scenarios. For example, if we increase the production of nuts tenfold, the model predicts what the likely land footprint of this would be, with uncertainty based on the variation in current global yields. The insights generated by the Delta model can show the nutritional importance of current crop production and the potential land and nutritional outcomes of changes in crop production. This is useful when planning what the future food system should look like in order to be truly sustainable. Want to explore the trade-offs between nutrition and cropland? Get in touch to use the model yourself.